Hi, my name is Michael Kazarinov and welcome to our Physics and Physical Science lab. Our next lab will be measuring the density of the various objects. To learn how to do it, we will try a few different samples. It will include wooden block, maybe metal cylinder, metallic cylinder, and piece of rock. Plus, we will use different techniques to do it. There are a few tools that we will need. Density cannot be measured directly. In order to do it, we will first measure a mass of the object. After that, we need to measure a volume of the sample and then use a formula, mass divided by a volume, that will give us the actual density of the object. And obviously, the unit for the density will be units of the mass divided by the units of the volume. In our case, it will be grams over centimeter cubed. To measure a mass for all of our samples, we will use the same device called triple beam balance. It's old-fashioned mechanical device. Obviously, we can do it a modern way using electronic balance, but what would be the fun doing that? So let's learn first how to measure a mass of any object. By the name, you can see that you have 1, 2, 3 beams and 3 number lines that will give you hundreds, tens, and units, ones of grams divided into 1/10 of the gram. So altogether, it will provide us with the 4 significant digits for our results. And if you can read here, the actual value will be given in grams. Obviously, 4 significant digits, it will be the upper limit or estimation of our accuracy. Most likely, our other measurement will be less accurate, so we will not expect anything better, maybe the 2 digits, so our result may be accurate, maybe about up to few percent, which is good for our lab anyway. So, how we will do the measurement of the mass? First, we need to see if our balance is balanced. And you can see it by watching the line on a moving beam and line on the frame. They're supposed to match each other, and if it's not, our balance should be calibrated. Then we will place that object that we want to measure on that plate, and we will start with the biggest weight, pushing it up, and there's the notches. We will move to the next notch. Click, it's not enough. So we need to move to the next notch, or it's too much, we will move in backward. Then we will add tens. 10, 20, 30, 30 may be too much. Let's go back to 20 and we will add ones. And then, after a little bit of adjustment, we get it to the balanced position. And then we can read it. So our mass will be 128 and 8/10. So that will be the same procedure for all of our samples. Now let's measure the volume of our sample. To measure the volume of our samples, we can use two different methods. First method will apply to an object of a regular shape. What is it, regular shape? Shape like that, rectangular shape or cylinder or a sphere, for which we have a formula which will give us the value of the volume if we know the sizes of that object. So what we need to do, we will just measure of three different sizes. The common mistake will be to take that object and try to measure three times obviously the same length. So we will try to measure this one 8, then 8 and 8, and that is not the right way to do. So instead of that, we can place it and make in our mind three different directions. That is length, that is the width, and that is the height, like similar to the room. Then we will measure the length and write it down, the width, write it down, and then the height and write it down in our lab report. The order in which you do it doesn't matter. The most important part to make sure that you actually measure a different dimensions. Now, if your object is not of the regular shape, then we need to do something different, and that another way to do it called a substitution method. And it could be applied to any sample of a regular shape, like a rock or metal piece or any object that will sink into the water. So first we will try to fill a measuring cylinder with some amount of water, and make it easier for you if you can just make it equal to easy to read value, for example 20 milliliters. Then we will slide our object in. But make sure before you slide it in, you will measure the mass. If you will do it in the opposite order, your sample will be wet and the mass will be different from the dry object. So you will slide it in, and then level of the water will move up. So we will read the final reading, and that will be, for example, 25. So original was 20. 25 minus 20 will give you 5 milliliters of water. So that substituted volume, 5 milliliters of the water, equal to the volume of the sample we put in. And we know that 1 milliliter of the water had a volume of 1 centimeter cube. So we can say that the volume of our sample is 5 centimeters cube. And that is an easy and quite repeatable way to measure volume of the sample. The only problem is your cylinder should be as precise as you can find, and in many cases it's not very precise, so we may measure up to maybe second digits, for example 21, 22, which will give you 2 significant digit precision, which is not very good. But we will use it in our experiment because that is the simplest way to do it.